Let plane 1 be the one determined by the vectors I and I plus j. And let plane 2 be the one determined by the vectors I minus j and I plus k. Now a vector that is perpendicular to plane 1 is given by the cross product of vectors I and I plus j, which can be expressed as a determinant with the first rows being I, j, k, the second row being the components of vector I, which is 1, 0, 0, and the third row being the components of vector I plus j, which is 1, 1, 0. This simplifies to be equal to k. Now similarly, vector perpendicular to plane 2 is given by the cross product of vectors I minus j and I plus k. This can be expressed in determinant form. The first row is I, j, k. The second row is the components of vector I minus j, which is 1, minus 1, 0. And the third row is the components of vector I plus k, which is 1, 0, 1. This simplifies to minus I minus j plus k. Now the vector along the line of intersection of these two planes will be normal to the vectors perpendicular to planes 1 and 2 and is therefore equal to vector k cross minus I minus j plus k. This can be evaluated in determinant form, with the first row being I, j, k, the second row being the components of vector k, which is 0, 0, 1, and the third row being the components of vector minus I minus j, k, which is minus 1, minus 1, 1. This is equal to I minus j. Therefore, vector A in the problem statement along the line of intersection of the two planes can be equal to plus or minus I minus j. Now let the angle between vectors A and I minus 2j plus 2k be equal to theta. The dot product of vector A with I minus 2j plus 2k is equal to the absolute value of vector A times the absolute value of vector I minus 2j plus 2k times cos theta. Therefore, cos theta is equal to A dot I minus 2j plus 2k divided by the absolute value of vector A times the absolute value of vector I minus 2j plus 2k. Substituting the value of vector A obtained above, we get plus minus I minus j dot I minus 2j plus 2k divided by the absolute value of plus minus I minus j times the absolute value of I minus 2j plus 2k. This is equal to plus minus 1 plus 2 plus 0 divided by square root of 1 square plus minus 1 square times square root of 1 square plus minus 2 square plus 2 square. The numerator is equal to plus minus 3 and the denominator is equal to root 2 times root 9. Root 9 is equal to 3. It cancels with the 3 in the numerator, and therefore the value of cos theta simplifies to plus minus 1 upon root 2. Now when cos theta is equal to 1 upon root 2, theta is equal to pi upon 4. And when cos theta is equal to minus 1 upon root 2 or cos 3 pi upon 4, the value of theta is equal to 3 pi upon 4 in this case. Therefore, the angle between vectors A and I minus 2j plus 2k is either pi upon 4 or 3 pi upon 4, which is the required answer.